Hi students, welcome to another class of Smartly Learn. In this video too, we will continue to evaluate multiple functions of alpha plus beta or alpha beta given a polynomial. Now let us go into the question. If alpha and beta are the zeros of the quadratic polynomial, p of x is equal to x squared plus 5x plus 4, find the value of 1 by alpha plus 1 by beta. The second one is alpha by beta plus beta by alpha. The third one is alpha power 4 plus beta power 4. Now let's start noting the polynomial. So the input function or polynomial is x squared plus 5x plus 4. Now let us calculate the alpha plus beta and the alpha beta values. So alpha plus beta is minus b by a. So it is minus 5 by 1. So it is just minus 5. Alpha beta is c by a, which is equal to 4 by 1. So just 4. Now, what is the expected calculation that we are needed to do? The first subdivision was 1 by alpha plus 1 by beta. The second subdivision was alpha by beta plus beta by alpha. And the last one that we were expected to calculate was alpha power 4 plus beta power 4. So let's start with the first case, which is 1 by alpha plus 1 by beta. So 1 by alpha plus 1 by beta, I'm going to take the LCM for that. So means the denominator is alpha beta. Do a cross multiplication in the numerator, which is beta plus alpha. Alpha plus beta and beta plus alpha both are same because they are commutative. So the numerator, I'm going to substitute. This is minus 5 by 4. So this is the value for 1 by alpha plus 1 by beta, minus 5 by 4. Now let us calculate the second one, which is alpha by beta plus beta by alpha. Again, I'm going to take LCM. So the denominator is alpha beta. But when I multiply the numerator, cross multiplication fetches alpha square plus beta square. So if I know the value of alpha square plus beta square, I can simply substitute and evaluate. So let us calculate that separately. Alpha square plus beta square is equal to alpha plus beta the whole square minus 2 alpha beta. I'll show how this is getting derived. We know that a plus b the whole square is equal to a square plus b square plus 2ab. So if I need the value of a square plus b square, I'm going to bring the 2ab here, making it a plus b the whole square minus 2ab. So that is what we have done here too. Alpha square plus beta square is alpha plus beta the whole square minus 2 alpha beta. Now we already know what is the value of alpha plus beta, that is minus 5 the whole square minus 2 into 4. So this is 25 minus 8, which is going to be 17. Now the value doesn't stop here. I'm going to carry over that here. So this is 17. We already calculated the value of alpha beta as 4. So the value alpha by beta plus beta by alpha is going to be 17 by 4. The third was alpha to the power 4 plus beta to the power 4. Now treat this as alpha square the whole square plus beta square the whole square. We just now wrote the formula. A square plus b square is nothing but a plus b the whole square. So here a itself is alpha square. So alpha square plus beta square the whole square minus 2 alpha square beta square. Now in this numerical, we have already calculated the value of alpha square plus beta square in the previous step, and we knew that value is going to be 17. So I'm going to substitute this directly as 17 the whole square minus 2 into, this is nothing but alpha beta the whole square. So this is 17 the whole square minus 2 into 4 square. So 17 square is 289. 4 square is 16. 16 into 2 is 32. So 289 minus 32, which is 257. So the last value is 257. In the next video, we will try to generate a quadratic polynomial or zeros are given, but this time I'm going to make the zeros a little bit complex by introducing irrational numbers as part of the zeros. See you in the next video. Bye. Please extend your support to me by subscribing to my channel Smartly Learn. You can also reach out to me through my website www.smartlylearn.in for more practice worksheets. Thank you. See you in the next video. Bye.